Yeah. Can you see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So, as you know that I'm going to teach you the second paper, Mathematical Economics. And I'm going to start with the basic concepts. Uh, the first module, the basic concepts part, I'm going to teach from Binmore's mathematical analysis. I'm going to cover the first 4 or 5 chapters. You can, there's no need to buy the book, although it's available and is fairly cheap. It's better if you download the book. I'll send you the link if I haven't sent it already. And I'll show you how to download the book. Apart from that, I'm going to mainly teach from, in the first semester, I'm going to teach from the second book, Hoy's Mathematical Economics. And another book that is very useful is Chiang and Wainwright, Fundamental Methods of Mathematical Economics. So Hoy and Chiang, both these books you should buy. Buy the hard copy, you will require it. I will not teach too much from Chiang in the first semester, but from the second semester, you will find that Chiang is very useful. MD will cover a lot from Chiang's book. So, Binmo's book, download. But Hoy and Chiang try to get hold. I mean, if you can't come to College Street, then just buy the book from Amazon. Another book that is useful is Silverberg and Soon, Framework of Economics. But this also you can download. There are several parts which are very useful, but it's something which you need not buy. Okay. Now, I think all of you know what sets are. What is a union, what is an intersection, and so on. Right? Is there anyone who doesn't know what sets are? Okay. So I'm going to just go through this set theory part very quickly. A set is a collection of objects. The objects are referred to as elements or members of the set. So if X is an element or member of the set S, then X belongs to S. We say X. This is the sign for belongs to. And if Y does not belong to S, then we just put a slash through it. So we can specify a set in two ways. If it's a small number of elements, we can simply write them down. But if it is infinite or even if it's very large, then what we generally do is we write it in this format, in a mathematical format. Now you should be aware of what is a null set, what is a subset, and the difference between a subset and a proper subset. Can someone tell me what is a null set?
The set where there
A
is
null
no
set
There are
is a
no
set which
elements.
does not
There's
contain
no
any
element.
elements.
Okay, very good. Who was it?
Sir, me, Samadip, and much more, many students.
Okay, so many students. Okay. And what is the difference between a subset and a proper subset? Let us suppose you have two sets, X and Y, and we say X is a subset of Y, and let us say X prime Y prime is a X prime is a proper subset of Y prime. What is the difference?
Sir, the difference is, sir, I think
Okay, yeah,
in subset there is only some number of elements included in the other other set, whereas in proper set there is the full number of sets, full number of elements.
yeah. So in case of a, if you just specify subset, Let us suppose the initial set has 10 elements. A subset can contain 1, 2, 3, even all the elements. Okay. But a proper subset means that all elements are not in the subset. You have at least one element which is dropped. It's a smaller set from the original one. In other words, suppose you have a set like this 1, 2, 3. So if you just specify set, it can be like this, it can be like 2 members, 1 member. You can also have the original set is also a subset of itself. But when you are talking about a proper set, we have to drop at least one element. So the number of the proper subset is less than the number of the original subset. But if I just see subset, it is like this. It can be equal to, it can also be less than. But here, proper subset, you have to drop at least one element. Union and intersection, what is the difference?
Union means like two sets where all the elements are combined together. For example, if in set A we have 1, 2, 3, and in set B we have 5 and 6, then the total, or A union B, will be 1, 2, 3, 5, 6.
Very good. And intersection?
So the common elements in both the sets.
Okay. So here you have only one common element, which is 3. So in terms of Venn diagram, this is the intersection, and in case of the union is the entire sets. Okay. Now, we'll be dealing with real numbers in this discussion. Now, real numbers, before coming to real numbers, we have to look at natural or whole numbers. This is given as 1, 2, 3. So, the strictly positive whole numbers. No fractions involved. When we are talking about integers, 0 is included and the minus values are also included. Rational numbers are any numbers that may be expressed as ratios of two numbers, that is x by y. You can have irrational numbers, which is root 2, e, and so on. Sorry, I've written pi, but pi is not a real number, is not an irrational number. There are some other numbers. Okay. Now, real numbers comprises natural numbers, integers, rational numbers, irrational numbers, everything. They generally satisfy some laws. The laws of addition, subtraction, multiplication, division. In addition, we can manipulate some of the inequalities. So the first law is transitivity. If A is greater than B and B is greater than C, then A can be said to be greater than C. The second law says that if A is greater than B and C is any real number, we can simply add C to both sides the inequality will remain like this. So A plus C greater than B plus C. In case of multiplication, if C is a positive real number, this is important. If C is a positive real number, then the sign remains same. So A greater than B implies AC greater than BC. But if C becomes negative, then the sign reverses. So A is greater than B, but AC is less than BC. Okay, I think it is best if you can, when I'm showing a slide, you write down the main points of the slide. And if you require some time, I can continue to hold on to the slide till you finish writing it down. Okay,
So,
just tell me. Yeah.
so can you show the example of the fourth point? If A is greater than B and C is less than 0.
Yeah, just one second. Right? And let us say C is minus 2. So we have minus 10 and minus 6. Which is greater?
Minus 6.
Yeah.
Yes, sir.
Okay. Now, roots. So if y is strictly is a non-negative number, that is it's either 0 or positive, this exactly one value of x such that y equal to x to the power of n. Okay, the value satisfying the above equation is called the nth root of y. Okay, so note that I mean, if we take, for instance, so let us say y is equal to 4. Sorry, no. Let us suppose x is equal to 4 and n is equal to 2. So y is equal to x by n. So, not this. Let's cross it. So sorry, y is equal to 4, n is equal to 2. So this is equal to x. So half means is the square equal to x. So note two things, that what is the value of x? It is 2. So both minus 2 and plus 2 will satisfy this equation. Okay. So this equation is satisfied by two values of x, minus 2 and plus 2. Okay. So this again you can know that we can write this as m, instead of writing it as n, we can take r, define r as m by n. So y to the power of r is m by n. We can write this as in this form. We can break up this part. If r is a negative number, then you know that it becomes the reciprocal. Like for instance, if y is minus 2, it becomes, we can write it as minus 2. And if the power is 0, it is always 1. So 10 to the power of 0, 9 to the power of 0, all of them are equal to 1. Modulus.
Sir, please show the last page once.
Sir, is 0 to the power 0 is also 1.
That is the only exception. So this will hold for y positive.
And sir, for y less than 0, will it also hold good?
এইটা কি 1 হবে? না, I don't think so.
So 0 to the power 0 is 1, it is showing.
Huh? 0?
So 0 to the power 0 is 1, it is showing in Google.
In fact, sir, also for the negative numbers, it is also showing 1 only. It may be wrong also. Actually, we can't trust any site for this
Yeah.
It is coming -1.
minus 1. Oh no.
That's my pen. See over here, in these two cases, it is greater than equal to 0. Here, y has to be positive. Then this law will be satisfied. Okay. We also write this by r. Okay, I'll check these two and I'll let you know in the next class. Okay. Next we come to modulus. In case of modulus, modulus x is means that x can be either greater than equal to 0 or it can be a negative value. Okay, so that means if I write x can be either 6 or it can be -6. Now we have certain theorems that we take x the minus of modulus x is less than equal to 6, plus of modulus x is greater than equal to x. Let us take a value, let us say 10. Okay, so modulus minus modulus 10 is minus 10. So this is less than, strictly less than 10. Now you can also take, it can also be minus 10. So this minus minus makes it plus. So that is why it is equal to. You have this greater than equal to. And similarly, we can also write this is the 10 x.
Sir,
We are taking plus modulus. So it can be either 10 এখানটা আমার একটু ভুল হয়েছে বলছে actually the problem is that okay, if I have to show it, give me 2 minutes please. I want to I'm feeling a bit thirsty. I'll bring some water. Okay. Sorry, I think I got disconnected, right? Just wait a minute. Okay. So let's look at the first theorem. So from the definition of modulus, we either have x greater than equal to 0 or we have x negative. Okay. So that means minus a modulus x, right? It is either positive or 0. This will be less than equal to 0. Yeah, x equal to 0 is this equal to, and x greater than 0 means minus x will be less than 0. So this is obviously, from this is obviously greater, less than equal to x. So we have proved this part. X is equal to, in the second case, this x negative, we have minus x is equal to x. Okay, the minus cancels out. So this is strictly equal to 0 because it's negative. So this will be less than x.
Sir, I have one doubt, sir.
So if you just cross this out, you have this part. हाँ बोलो.
Sir, for this condition, sir, minus of mod x less or equal to x less or equal to mod x, sir, it is holding good for all the values. But sir, I just want to ask, sir, why the less than is used, sir? This I can't understand actually.
কোন জায়গাটাতে বলো তো, আমি ঠিক বুঝতে পারছি না কোশ্চেনটা।
মানে স্যার ওটাতে ইকুয়াল টু দিয়ে দিলে হতো, মানে লেস দ্যান এর কাজটা ঠিক বুঝলাম না।
কোনখানটা, কোন জায়গাটা বলো, এই জায়গাটাতে?
হ্যাঁ হ্যাঁ হ্যাঁ।
মানে তুমি বলছো ইকুয়াল টু দিয়ে দেওয়ার?
হ্যাঁ হ্যাঁ।
এইভাবে তুমি বলছো লিখতে আর কি। এইটে এইভাবে বলছো তো?
হ্যাঁ হ্যাঁ হ্যাঁ।
আচ্ছা,
x নেগেটিভ হলে তাহলে তো হবে না।
হ্যাঁ এক্স্যাক্টলি, ইফ দ্য x is negative then তো it will not satisfy.
হ্যাঁ, ইকুয়াল টুটা হবে যখন তোমার x ইজ ইকুয়াল টু 0, কিন্তু x
আচ্ছা।
যদি তোমার, if x is equal to 0 then we can say this,
otherwise less than
the inequality will hold.
Okay sir, okay sir, I can understand now. Thank you sir.
Now for any real numbers a and b, the modulus of ab, the product, can be written as the product of the moduluses. So again the proof is two is like this. Okay. Now for the third and fourth theorem, I need a little bit more space. So A and B are real numbers in that case. So we start with the left hand side and we take the square of this. So this is equal to A plus B whole square. Because whether it is negative or positive doesn't matter. So it is equal to we write the full form. This can be written as okay. Achha. Now we have proved that x is less than equal to the modulus of x. Sorry, this equal to should not come. I'll change this. So there's no problem with this these two components. But if we put in right, so we had E, now we are putting in modulus of E. When we put modulus, it will become greater, this will become greater than equal to. This is not minus. I'm going to write the sign. Okay, modulus of AB is equal to modulus of A into mod of B. So I'm just changing this part. It is still, it will be equal to. Okay, now if you look at the term, this has become simply so this is equal to this. If you simply cross out the square, So this part follows from okay. Sorry, it should be if and only. Okay. The last theorem is
Sir, I think we're missing a plus symbol in the last statement.
yes.
A mod plus B mod.
Yeah, you are right. I've written product
So,
by mistake. Yes.
so, so that line, so A modulus square plus 2 modulus A modulus B. So
Wait,
there
wait.
should be a
Let
plus
me.
sign.
Where in this line?
Mm, so first, second, third, fourth line.
1, 2, 3, 4. Yes, here also.
Yes, sir.
Yeah. For any real numbers, okay, so we define A as D and B as B is defined as C minus D. Then we apply the triangle inequality. So that means A plus B is less than this. Okay. Now A is D and B is C minus D. Right. You can take this to the other side. It is C. Sorry, you can take this one. Sorry. I've written minus. C minus D. This is modulus. Sorry. এখানটা তো মডুলাসটা ভাঙার দরকার নেই. Don't break it. Okay. So you keep this modulus. You just take this over here. This is C. You just take this over here. So it's modulus C minus modulus D. And this is modulus of C minus D. Okay. we come to the what we call the continuum property. Do you know who this is? Who is this person?
Bold.
Very good. It is Bolt. And why is Bolt famous?
Fastest man
For
is
those who
the
are not,
Fastest
he's the
one.
fastest man of Earth. Now suppose, can we have a bet? I know it's illegal to bet, but let us have a bet. Bolt will race against a person of my choice. And I bet that Bolt will not be able to defeat that person. Will you accept this bet? Bolt's hands, legs, they will be free. Bolt will have the choice of track. It's a plain athlete's track, everything. The only thing is that person will have a handicap. That person will be placed a few meters before Bolt. Bolt simply has to catch him up. Bolt will have as much time as he wants. He simply has to catch up with with the person that I nominate. Okay, so it's something like this. This is Bolt. He's going to run this way. This is the person of my choice. He's going to run this way. And Bolt will simply have to catch him up. And I'm betting that Bolt will never be able to catch him up. So who will accept this bet? Or do you want to see the person?
So let us first see him.
It's a magnified picture. Bolted ছবিটা ছোট করা হয়েছে, একটা বড় করা হয়েছে, obviously.
Yes, sir.
Now will you accept the bet?
Probably no.
Why?
Because the tortoise is very slow, sir.
No, you have to bet that Bolt will catch him up. I'm betting that Bolt will not catch him up.
Then we need to calculate it, the distance and the speed. Then we may say that.
The speed of a tortoise?
And the distance between them.
না না, মানে Bolt will have sufficient time. মানে কোনো ফিক্সড ডিস্টেন্সের মধ্যে ধরতে হবে সেরকম নয়.
Oh.
Bolt's objective is to catch up. There's an infinite road. Bolt will just have to catch him up at some point. They both start at the same time. Actually, if you want, I can even give the distance. 20 meters.
Then he will be able to catch him very soon only. I think so, at least.
So will you accept my bet? One
No, sir.
Cadbury chocolate.
No, sir.
No. Will anyone accept my bet?
Sir, I accept your bet.
Yes, sir. Yes, sir. Why not?
Okay. So who are the persons? চলো এটা রেকর্ড করা হচ্ছে. Let me see. Who are these persons? These bold persons? Anyway. So let's start the race, shall we?
Yes, sir.
Yes, sir.
Achha, remember this is being recorded, so I have your voices. So because Bolt is just running, but this person will have to carry his house, we give him a certain meter. Okay? Wait, let me set it. So this is Bolt. This is tortoise. And this is 20 meter. Okay? Achha. Okay, let us suppose bolt runs up till here, runs 20 meters. Okay, and reaches this point, right? He will take some time, whatever be the time is irrelevant. 5 minute, 10 minute, 1 ঘন্টা, he reaches this point. By that time, the tortoise, so let us call this B1. By this time, the tortoise will have moved forward T1, right?
Yes, sir.
So now bolt has to run up till this point. Whatever is this distance, bolt has to run up to this point, right? So in a certain time, again it's irrelevant, he comes over here. So when bolt comes here, the tortoise will have advanced a little bit, T2. So bolt again starts running and he comes to over here. By this time, the tortoise will have moved to T3. So will bolt ever be able to catch him up?
Sir, Bolt will catch him if his speed is more than the speed of
Exactly.
the tortoise.
Exactly.
Yeah, certainly.
So he will catch him, right?
How? See, when bolt reaches here, the tortoise has advanced over here. When bolt comes
It's just
to
like
this point,
someone
the
running.
tortoise has advanced a little bit further. So the distance
Maybe
between
Bolt
them
will
will
like
come down.
go beyond the time. Maybe by the time the tortoise reaches from T1, T to T1, Bolt has already reached T1. Hello.
No, see
Yes,
the
sir.
thing. Wait a minute. Actually, let
Sir,
me adjust a bit. Huh?
so when the
Yeah.
tortoise is at T and he moves to T1, by that
Hmm.
time Bolt will not remain standing, na?
No,
Bolt
no.
will also
See,
move
when B is moving from here to here, the tortoise has moved from T to T1.
T1.
Right. Now we are taking
Yes, sir.
B2. Okay, B1 is coming to T1. Bolt comes here very fast. But by then, the tortoise will have advanced a little bit further. So when bolt reaches the position of the tortoise will have gone a little bit ahead. Not much, but a little bit ahead each time.
Sir,
So
sir.
the distance continues. However, with every passing second, or you can say, the distance also decreases between them.
Yeah, but will bolt ever be able to catch him up?
Sir, if we keep
In
expanding
Another
even
definitive,
before he catches up infinitely, he won't ever catch up.
Exactly. So how many chocolates am I getting?
Sir, it's just like a man and a car racing. Like someone is walking before us and the
Sir,
car is
doesn't the
coming.
answer depend
Car
on
will catch
any
us.
preference of time? It's how we look at time.
No, but just think about how I have framed the problem. The way that I have framed the problem, bolt will never be able to catch up with a tortoise, right? But do you think that it's very logical? The fastest man racing a
No,
tortoise.
it's not logical.
no, sir.
Yes, sir.
Yeah. So how do we resolve the paradox? Okay. So what we can see is that we can simply assume that it's basically, as one of you have said, it is convergence. Okay. So the initial distance that bolt travel. So this was the position where the tortoise was standing. This is the 20-meter gap. We call this x0. So bolt initially runs this amount, right? Then in the next round, what happens is the tortoise, by the time bolt reaches here, the tortoise has gone up till this much, x1. So now what is the total distance that bolt has to travel right from the start? x0 plus x1, right? But by then the tortoise has gone up to x2. So how much does bolt have to travel? x0 plus x1 plus x2. Okay. So it goes on like this, x0 plus x1 plus x2 plus x3.
Sir, can
Then
you tell this once more, sir? এটা ঠিক বুঝতে পারলাম না।
আচ্ছা, see, bolt is over here and the tortoise is over here. But think of it in this manner, that the bolt reaches, when the bolt reaches the position of the tortoise, the race is stopped for the moment. No one can move. We have a drinks break and then again the race restarts. ঠিক আছে?
হ্যাঁ স্যার।
So when the first drink break occurs, how much has bolt run?
Sir, x naught.
X naught. Only in the second drinks break, how much will bolt run?
x1.
X1. So what is the total distance?
X naught plus x1.
Acha. In the third round?
Sir, x2 will be added.
And so on. We go on adding x2, x3 like this.
Yes, sir.
Until bolt finally catches up with the tortoise. Okay.
Yes, sir.
So when bolt catches up with the tortoise at some end, this total distance, suppose he catches up with the tortoise at x after running x distance. ঠিক আছে? So this x is greater than all these distance. You can say that x is the smallest real number that is larger than all these numbers. Okay, so if bolt catches up with a tortoise at this distance at x, so this is x, so you are simply adding on. X is the smallest number, which is the addition of all these numbers, x0 plus x1 plus x2 plus x3, like this. So this is actually a paradox which was stated by a Greek philosopher, Zeno. So obviously he didn't, the tortoise didn't have to race against Bolt. He had to race against Achilles. But I thought that Bolt would be more interesting. So actually what this happens is, this is called the continuity problem. You have a set of real numbers. Okay. Let us suppose the real numbers are 1, 2, 3, like this. And suppose there is some number h which is greater than equal to all these numbers. Okay. Like, let me give an example. Suppose this is 10, and let us suppose h is also 10. So if we suppose x is 1, or let us suppose we go up to 9. In that case, it is strictly less than h, which is equal to 10. And if x is equal to 10, then it is equal to h. Right? Or we can simply set h equal to 10.5. In that case, whatever is the value of x, it is always less than h. H is called, if h exists, then we say that a set S is bounded above. Okay, so for some
Can
h,
repeat
x
one
is.
second.
Achha. Let me state this, then I'll go back. So for some h, all the elements of the set S, x, is either equal to, it can be less than h, or at most it can be equal to h. Okay, so we are talking about, okay, so coming to this example, suppose we have a set okay, x is any of these numbers. So if x is 1, it is less than h. H is suppose 10. X is 2, again we have h. X is 9, it is less than h. But if x is equal to 10, it is equal to h. Okay, so based on this, we can say that if there's a number h such that this property is hold, then we say S, the set S is bounded above. Okay, there's an upper bound of the set. So just remove the numbers. Okay, so these are all numbers. This is the set numbers. So we have an H. Okay, H can. Now remember, that, now keep in mind one fact.
So is this a number line?
This is a number line. Let's say for simplicity, we have this. So can you say what H is for this set? Oh, let me just change it. Suppose you have x equal to 1 to 100 and it is bounded above. What can be the value of h? Can h be 10 now?
100 or above.
Yes, sir.
100, sir.
100 or above.
100. Anything greater than 100.
Can h be 100?
Yeah, it can be 100 because you told that less or equal to, then I think
Yeah.
it can also be 100.
Okay. But h can also be 110.
Of course, sir.
Yes, sir.
It can be 110 also.
Yes, sir.
Okay. Right. So just keep in mind this fact that it need not be satisfied as an equality. We can also have h is less than h. That is also possible. So h is called the upper bound. Now, you have many such upper bounds. I mean, what are the possible values of h? They start from 100, 101, 102, like this. So you have a huge, infinite possibilities. Now, out of these possible upper bounds, take the smallest. This is the smallest. This is called the supremum. Okay. Let me give another example. Actually, it's difficult to see the pen, where the pen is located. So what are the possible upper bounds?
15 and above.
15 or more than 15.
15, 16, 17, 18 and so on. What is the lowest of them?
15.
So 15.
This is the supremum. Okay. So just as you have the upper bound, we also can define a lower bound. Can you tell me what is the lower bound for the first set? 1 to 100.
1.
100.
No, what is the lower bound? See, in upper bound, we are
1.
taking, yeah, we are taking this. For upper bound, we are setting. For lower bound, what should be the definition?
It must be the lowest number or lower the number that is lower than the
No,
lowest
it should be
number.
this. Yeah, it should be this. So if you are starting with 1, what are the possible lower bounds?
Sir, 1, 0,
200.
minus 1, minus 2,
99.
minus 3.
Minus 1, so on. Which is the largest of them?
So
This one.
1.
1. Of
1.
course,
This
1.
is called infimum. Okay. Over here, what are the possible candidates for the lower bound? And what is the infimum?
So 1.
No.
So which one?
5. It's starting from 5.
Acha, what's that?
Oh, infimum is 1, sir. 5, 5, 5, 5, 5.
5, sir.
So it will be 5, 4, 3, so on. Infimum is 1. Okay, so what sign do we put over here? I've deliberately kept a blank over here. এখানে কি লিখবো? What will I write over here?
Less than or equal to.
Less than equal.
Yeah, this will be
Less than.
less than equal to. So for some L, X will be, again what will be the sign?
Less than equal to.
Question.
More.
Sir, x greater.
Sorry, X
greater
will be
than.
greater than.
Greater
Yeah,
than.
X is. X greater than. So you can see that this is the set, and any point over here is a lower bound. So L is called the lower bound, and infimum is, we know what is the supremum, smallest upper bound.
Largest lower bound.
Of the set. Okay. Is it clear? Okay.
Yes, sir.
Sir, can you show the last page once more, sir? লেখা বাকি ছিল।
Sir,
হয়ে গেছে?
sir, will you post these recordings?
Yeah, I'll post the recordings.
Yes.
So if it's just one or two things which you don't note or you want to go over, I'll give you the YouTube channel. You can subscribe. So whenever I post something,
No, sir, like the notes that you are giving, sir, we need to copy it.
You can, if you want, I'll hold on. There's no
No, sir.
hurry.
No, sir. No,
Yeah.
sir.
Yes, sir. Yes.
ठीक है.
No, we wanted to ask that you will post these
Yeah, yeah.
recordings in the Google
I'll post.
Classroom, right?
No, I'll post it in YouTube. So, and send you the link
Can you
in
give us
Google
the link to
Classroom.
your channel?
I'll post it so
Thank
you
you,
can
sir.
check it up later. Or you, if you have a YouTube downloader, you can also download it. Actually, the problem with Google Classroom is whatever I'm posting goes into my Google Drive. Okay. So if any, suppose you have a non-empty set of real numbers. So this is the real numbers, okay? And it is bounded above. So the bounds can be any of them. They start from the maximum point, maximum element, and then it just goes on. Any of these points over here constitutes an upper bound. The smallest of them, the smallest of all the possible age is the supremum. On the other hand, if you want to look at the infimum, sorry, we take the smallest amount, b, small b, and any of these points over here constitutes the lower bounds. But the maximum of them, okay, that constitutes the infimum. So, which is bounded below has a, what should I write over here?
Largest.
Sir, it will be upper or lower?
Actually, I was copying it. You are right. I was
I was
copying it.
confused by seeing it.
It's difficult to write down, to retype everything. So what we do is generally we copy it. And then I forgot to change it. And even if you can't copy, can't copy it, or you want to go through, I'm just going through Binmo's book. So if you read Binmo's book, that will also be sufficient. This is the second chapter of Binmo's book. This starting from the Continuum Property. The first chapter was this modulus, root, and so on. Okay. Now the maximum and minimum. So if you have a set which is obviously non-empty, the largest element, capital M, okay, this is called the maximum of the set S. So suppose the set is 1, 2, 3, 4. What is the largest element? It is 4. So we see that 4 is the maximum of S. So if you have a certain, you can identify M, S is bounded above. Now suppose you have a set, you define the set X greater than 2. Can you tell me what is the maximum? Of this set? What is N?
I guess 1.9 and something.
M is 1. Why?
No, sir, no, sir. Three. Three, anything can be.
3 or more.
Three or more.
Sir, it cannot be defined, sir.
Yeah,
So
infinity, bro.
infinite number of elements.
Yeah. So X starts from 3, it goes up to 4, 5, 6, so on. It goes up. So we can't identify a maximum element. Right? It cannot be identified. What are the bounds? Does it have an upper bound? We'll come to the supremum later. But what is the upper bound of this set? Does it exist?
Sir, it will be infinite.
Does not exist.
Yes, sir, it will be infinite.
H does not exist. There's no upper bound. Okay. And therefore, there's no question of supremum. Right. But suppose we say S is what is the maximum of this set?
17.
17.
And what are the possible candidates for H?
Greater than equal to 17.
17, 18,
17,
so
18,
on.
19, 20, up to so on.
And the supremum is the lowest element. Okay. So, generally what we see is if it has an upper bound, then the maximum and the supremum coincides. If S has an upper bound, then the maximum element, the largest element of the set, is equal to the supremum. What is the corresponding concept theory for minimum? Take the set that I've written, x equal to 2, x is greater than 2, equal to 2 and less than 17. What is the lowest element in this set?
2.
Minimum 2. What are the possible lower bounds?
And less than equal to 2.
It's 2 minus 2, 1, 0, so on. So in this case, if S has a lower bound, then
Minimum is equal
Inferior.
to infinite.
minimum of S is equal to infimum of S. And let us consider this set. What is the minimum?
It's a no minimum.
Sir, it doesn't exist.
It doesn't
Yeah.
exist.
হয়ে যাচ্ছে এক্ষুনি শেষ করি So it's the minimum. It doesn't have a lower bound. There's no lower bound. It doesn't exist. And therefore, the property that you have written will not hold in that case. Okay, so let's just check. If S has a smallest element, small m, we call m the minimum of the set. S is bounded below then the minimum of the set is equal to infimum of S. Okay. So we have a meeting, and I'll end my class today.
Sir, can we get the link for your YouTube channel?
I will post it in the Google. Actually, it takes a little bit time to download and upload it again.
Okay, sir.
I'll do it by tonight.
Okay, sir.
And if you subscribe, or I'll post the link. But if you subscribe, as soon as I post anything, you will get. I think you get the information.
Yes, sir. Okay, sir.
And don't worry,
Don't
I'll
worry,
also.
you also have
I'll
to subscribe to your channel.
Yeah, I'll also show you something over here. I'll send you the link to this also. This site is called LibGen. Okay. So bin mode. Let me search by bin mode.
Sir, the book is also available in Flipkart. The price is just 125. I think we can buy it also.
Yeah, but you can also.
Sir, you have previously sent the link of Binmore book in our
Binmore,
class.
Okay, but you can also just keep in mind this. To this, see mathematical analysis. So if you click over here, huh? এ বাবা, আজকেই তো আমি গেছিলাম। পিএইচডি রুম মানে কোনটা, যেটা লাইব্রেরির পাশে? ওই রুমই তো আমি গেছিলাম। হ্যাঁ,
এসি প্যানেলটা দরজার দিকে কি হয় অনেক সময় লাইফ সায়েন্স এরা এত ঠান্ডা মেশিন না, পুরো বর্ষা গেছে তো তো ছাদটা পুরো
সোয়েট
ড্যাম্প হয়ে
করেছে,
গেছে সিলিং। হ্যাঁ,
সোয়েট করেছে।
সোয়েট করে হয়তো পড়ে গেছে, কি হয়েছে কত জানি না, আমি তো বুঝতে পারছি।
ঠিক আছে, আমি শেষ করে দিয়ে আমি করছি। So if you click on this mirror, you have to click on get, and then the file will come. So you can download different books from here. Chiang also, Chiang Hoi. You can download these books, Alpha Chiang, but this is the 3rd edition. Silverberg's Framework of Economics. The problem is it doesn't have a very good search engine. So Framework of Economics you might not be able to get so easily. This is shorter, so you can check this. So, like Google will give you an approximate search, but LibGen, in case of LibGen, you'll have to give the exact term. Even then, you might not get it. So if there's a slight spelling mistake, you won't get the. Okay, so keep in mind, I'll send you this link also, the LibGen link, so that if you require any book, you'll be able to download it in the future. I'll send everything by tonight. I think our meeting will end around 8. After 8, I'll send everything. Okay, so when is our next class? Wednesday.
So Wednesday.
9:30, whatever. I'll check it up and we'll meet again. If you have any questions. Okay. So Anyway,
Yes, sir.
whatever the time, if you have any problem, please let me know. I'll show the slides or discuss it again. Okay. Bye for now. And
Thank you, sir.
please bring the
Thank you.
chocolates. I think there were 5 people who lost the bet.
Yes, sir, let us meet. We'll all give you chocolates. Let the
Okay.
college reopen once.
সে আশা
Yes,
করো
sir.
না।
স্যার রিওপেন হবে তো?
Don't keep your hopes.
মানে হবে না?
The colleges are starting out here.
When see whatever we hear, as soon as we hear it, we will inform
And
you.
again, Corona, another curve rises and everything shattered.
Corona curve will not rise that much. It has become endemic. It will rise, but not as much as last year.
Oh, that's true.
So then what is the problem?
See, let's see what happens.
ওকে স্যার। স্যার খুললেই ভালো, আর পারছি না বাড়িতে।